Hey everybody, welcome back to Tech and Beer. I'm Calvino, and we're live again today from the Celtic Corner in Dartmouth, Nova Scotia. And today we're going to be talking about virtual reality. And I've got to be honest, this is a topic that really excites me. Ever since I was a little boy watching Star Trek on TV, watching my favorite characters go into the holodeck and explore these fascinating worlds that they could just spin up, I've been so excited for when this technology would actually become accessible and available to me. And we're going to be talking today to somebody called Devin Horsman, who is the CTO and virtual reality specialist at a company in Halifax called Arcturus Studios.
That's right.
I got that right. Thanks, Devin. Bailed me out already. And he's going to tell us how he's working on this problem and this technology. So welcome to Tech and Beer, Devin.
Hey, thanks
Cheers.
for having me.
No problem.
So, beer.
Beer, yeah, let's start.
Yeah.
Last time I got told we didn't have enough beer involved in the show, so we're going to start off with the beer.
Yeah, I've already gotten started.
Yeah, good job. And we're drinking the 9 Locks Dirty Blonde again, just because it's a great local beer. Mm-hmm. It's nice, it's fruity, and it's a wheat beer we learned today.
Yeah,
so.
That's what I'm all about.
Awesome. So tell me about yourself, Devin. What's your background? How did you get into VR? And yeah.
Yeah, so I was born here in Nova Scotia and grew up kind of in the woods out in Hubli. And from a young age, I was super fascinated with video games and technology. I kind of self-taught myself web programming as sort of a 10 to 15-year-old, and was really interested in that. Made websites for my friends, that sort of thing. Then I went and did a computer science degree. After that, I worked in a lab at Dalhousie called the Edge Lab, which was a human-computer interaction lab that did things like augmented reality, projection surfaces, multi-touch surfaces, and that sort of thing. This is in the kind of 2003 to 2005 kind of pre-smartphone era.
Okay.
So we did a lot of work with like Palm Pilots and
I remember that.
Smart boards, those sorts of things. And we did some experiments with these kinds of things called pervasive and immersive technologies. So they would be kind of unique input devices. We had something called motion tape, where you could kind of move the tape and use that as an input device. And we'd have that like kind of like lined up the user's arm, and we could kind of sense their arm positions. And all these sorts of things were kind of the things that added up into what's become immersive computing now. And immersive computing is augmented reality, virtual reality, and other kinds of mixed reality setups. So from there, I went into gaming. I did a few years working at a gaming company, and then I started this sort of cooperative kind of a cooperative think tank sort of thing, where we got a bunch of smart people together and we tried to solve interesting problems.
Okay.
That was called Twisted Oak Studios.
Okay.
I sold that company and started Arcturus in 2016 with a guy named Andy Stack, who's a former YouTube and Google guy, and Ewan Johnson, who's a former Pixar and DreamWorks guy.
Excellent. Those are some big companies for your partners to have worked with.
Yeah, they're amazing, and working with them has been the best.
Awesome. Yeah. Excellent. So what are some of the things that you and your partners are working on now? What's the kind of mission statement of your company?
Right. What we're trying to do is build immersive narrative experiences for immersive media. So a narrative experience is something that's narratively driven. Think of it like a film or a movie or a game, but story-based, focused around the story, characters, plot, that sort of thing.
Okay.
And immersive just means it's in virtual or augmented or mixed reality. And the user or viewer or player can go into the world and feel like they truly exist within it.
Right.
So they're immersed and they have presence in the world. Yeah. So to that end, we're working on sort of two different parts of that. One of them is, what is the technology that's needed to build these kinds of experiences that are convincing and can compete with things like film? And the other one is actually making the experiences themselves. Right. So that's the content side. So technology and content, we think they both sort of push each other. In order to make really good content, you need to make the technology that drives it. In order to know what technology to make, you need to be making content to explore that space.
And that's a little bit like, you know, there's lots of web developers out there, but there's not many companies that actually build the tools that help somebody create a website. So you're working on both ends of that problem. Yeah,
exactly. So we sort of sit in the space that is, like, imagine, to use something that other people might be familiar with, if you're a photographer, you use a camera and you use Photoshop. We're the Photoshop creators, so to speak.
Interesting.
Yeah.
So you must have a quite really strong team around you, not just your partners, but you must have a good core team of varied skills and experiences.
Yeah, we've got a pretty amazing staff. A lot of people I've worked with for, 5 years plus, and most of them are based here in Halifax. Which everyone's been a dream to work with. I love coming to work every day.
So let me get straight to the money question here. Like, how close are we to the holodeck? Like, is it, like, I want it now? Like,
well, it's interesting. We're a lot closer than you think.
Okay.
There's still a few places that are a little bit out of reach. A little bit science fiction, but sort of a lot of the main pieces, the pieces that you would have thought wouldn't be possible at this point are. So what are the pieces of the holodeck? What do we need to go from what we know of as consumer VR hardware today to sort of this idea of limitless space and interaction with realistic humans? So the few pieces. One of them is we need 3D live action photography. So we need something that looks and feels like video, but is viewable from all sides. You can walk around it. You can look behind a person. There's a parallax effect when you move your head, and these sorts of things.
And we must have solved that problem, I'm guessing. That must be...
It's not super solved.
Okay.
We're working on it. I'll tell you more about it in a second. The second piece is we need haptic feedback. So you need some way of that world interacting back with you. So if you put your hand against a virtual wall, you can feel the virtual wall. And if those sorts of things. And then the third piece you need is limitless space. You need to be able to go beyond the size of your room in the virtual experience you're in. So those are the three pieces, and the piece we're working on is the first one, the live action photography part of things.
Right. So you can tell me more about that.
Yeah, I'll tell you more about that.
And now, it's not just lots of guys with cameras.
So the way that works is there's a few different kind of competing technologies in this space. One of them is called free viewpoint video, or sometimes holographic video, or sometimes volumetric video. And the other one is called light field photography or light field video. So Volumetric is, they're both shot in sort of similar ways. You've got a huge array of cameras. An array is just like a set.
Yeah.
And oftentimes they'll be in like a dome or a grid configuration.
Okay.
They'll all be pointed inwards in a room. So imagine like 50 to 150 cameras, all aimed into the center of a sort of like green screen space. It doesn't need to be green screen, but it often is. And all of them are taking video in lockstep. So they all take a frame at the same time.
Yeah.
And all those frames are stored into some giant rack of disk space.
Right.
And then that's processed to recreate a model for every frame of that video.
Yeah.
And that's sort of where most of the companies are today.
Okay.
And you can get sort of a mesh sequence, which is just a set of three-dimensional models of this green screen set, and play those back in sequence. And it uses a lot of resources. So the problem we're working on is how do you make that, compress that data so that you can, say, deliver it to something like mobile phone hardware, or stream it over the internet.
Yeah.
And also, how do you make that data more flexible so that you can more easily edit the data or change the performances after they're captured, or touch up blemishes on the actors, those sorts of things.
Yeah.
Yeah. So the suite of tools we're making, it works in that space.
Okay. Interesting. So the tools that you make, that who would be your customers? Like, who are going to be the people that are like wanting to buy those tools?
Yeah. So
because they'd be quite big, large tools, I would imagine. Right? They're not, it's not like the photographer that's going to buy his home a kit and take it home with him.
Yeah. So you can kind of compare the progression of who our customers will be to sort of other technologies that have happened in the past. Like if you think of the digital camera, or the digital video camera, or those sorts of things. Like initially, you've got a lot of fairly large industrial uses or studio uses, and then it slowly moves down to a more prosumer and then finally consumer sort of use case. Initially, we'll be mostly working with sort of major movie studios, and some other like major VR content producers.
Okay.
And then slowly this sort of technology will make its way into the prosumer market.
Yeah.
And then finally, it should be an everyday thing and replace your sort of standard camera setups.
Yeah. Okay. So that's problem one. What about problem two?
Yeah, problem two. We talked about haptics. Haptics is kind of the most challenging of this set. One of the technologies that exists here today is, I believe it's actually, I don't know what it's called, but they have an array of these little, I think they're sonic. They're actually called ultrasonics.
Okay.
And they're like a grid of these little motors or valves that can vibrate, and I don't know if you've ever played with a jump rope. If you take a jump rope,
it's been a long time,
and you give one end to your friend, and you kind of wiggle your end, you get this kind of worm-like wave that goes down the end of it. But if you wiggle it once, it goes down to the end, and then it starts coming back at you.
Right.
Well, if you time that wave at the right timing, then as the wave comes back and as your wave passes it, they both sort of pass in the middle, and they create what's called constructive interference, and it makes a bigger wave, which is called a standing wave.
Okay.
It's the same thing that happens in a guitar when you pluck a string, and there's lots of other places where this comes up.
Yeah.
But basically, you get all of these little valves to to create the constructive interference in the same spot, and it creates a small pocket of air pressure in the air, kind of away from the array.
Okay.
And you can sort of put your hand over that pocket of pressure and feel it.
Okay.
And it can, and you can use that along with something like a leap motion or another depth sensor to kind of move these kind of virtual objects that are sitting in the middle of the air. So one of the companies doing that, I think, is called Ultra Haptics.
Okay.
Yeah.
Interesting.
It's a pretty interesting space.
So I find it interesting that you said that that was the hardest one, because I would have thought that problem number 3 would have been the hardest one with limitless space.
Right. Yeah, limitless space is interesting. Sometime around 2001, some researchers came up with this idea they call redirected walking.
Okay.
And the idea there is, actually, there might be a little video clip we have that I can show. It's called redirected walking.
Okay.
There we go.
So
this is some research from 2014, and what they're doing is this is just a little clip I found on the web before we came. So what's happening here is you have a real room, which is shown as a kind of red outline, where the person is walking around and the virtual reality setup is located. And then you have a virtual space. In this case, it's a maze that the user is navigating. And one of the kind of perceptive tricks you can use is that as you turn your head in your virtual reality headset, you need to see some amount of motion happen that corresponds to your head turn. But if it moves a little more or a little less, you don't really notice. Okay. So that's called rotation gain. And there's another kind of effect that if you're walking forward and somebody kind of turns the virtual space, but you don't turn your head, you'll move your head, you'll turn to correct for it. Okay. And you won't notice that either within a certain degree of range. So what happens is that as you're walking around your physical space, it's applying these rotational gains to your virtual movement and getting you to compensate for it. So you think you're walking in a straight line and you end up walking in an actual circle.
That happens to me on a Friday night.
yeah, maybe right after this.
Yeah, exactly.
So with this sort of technology, once you have a certain size of space, say, I think it's something like 40 feet in diameter, you can create a limitless virtual space and automatically sort of plot the path of the user to not run into walls.
So is there a speed limit as well?
I'm not sure about that. I don't have an answer for that one. I know that it's been used in a few places. I think the Void, which is a virtual reality location-based center, has used it before and given demos with this sort of technology.
Interesting.
I expect we'll see a lot more of it soon as kind of mobile 6 degree of freedom headsets become more popular.
Right. Fascinating. So tell me more about some of the stuff that you guys have been working on. I mean, thanks for giving me the kind of breakdown there for the holodeck.
Yeah.
Sounds like we're not quite there just yet, unfortunately, but it's good that we're making progress. So, but what else have you been doing? Like, what exciting stuff have you been working on? And
yeah, so we just released a fantasy VR experience called The Way of Kings, Escape the Shattered Plains, which is a adaptation of Brandon Sanderson, who's a science fiction fantasy author's book called The Way of Kings.
Yeah.
I can show a little clip of that, which is just a trailer for the experience.
Okay. Awesome.
And we can talk a little bit about it after.
Yeah, okay.
Some magic to the storm. Follow me. Clear this and we're through.
So this was developed completely here in Halifax, or?
Yeah. Well, our team is global. The lion's share of the development happened here in Halifax.
Awesome.
Yeah.
Fantastic. It looks great.
Yeah, thanks. So in the game, you play Kaladin, who's a warrior who's been kind of disgraced and sold off to slavery, and within the experience, you're sort of find yourself at sort of the darkest point in your life, and trapped at the bottom of this canyon, and you've just been sort of through the ringer. You've been strung up in this giant storm that kind of crosses the world on a regular basis.
Okay.
And as you've gone through this storm, instead of dying, you find yourself kind of with these newfound powers, and you're sort of learning to understand them and make your way out of this big canyon. Along the way, you come into some there's combat with some enemies, and a giant monster called the Chasm Fiend you have to defeat.
Okay.
Yeah, it's a really exciting and kind of blockbuster-like experience.
What platforms is it available on?
Yeah, so it's available on Steam and Oculus Store.
Okay.
Yeah.
Excellent. Okay. Well, hopefully some of our viewers check that out. I know I'm going to take a look later on. Cool.
Yeah, I hope you get a chance to.
Yeah. Excellent.
So in doing that, we learned all sorts of new things about what works and what doesn't work in virtual reality. One of the things that the characters learns to do is to change gravity, the apparent direction of gravity.
Okay.
And gravity is really challenging to deal with in VR, because if you apply an acceleration that the user themselves doesn't see or sense, then their inner ear, which has this little gravitational sensor, will disagree with what they're seeing, and you'll get sick.
Interesting.
So you end up with this sort of design problem, which is how do we give someone the experience of changing gravity and walking on the walls without making them sick. And so we had to make all sorts of different prototypes and iterations of how this effect could work, and it's super interesting to try all of them out, and then kind of like some of the days you just end up motion sick for 2 or 3 hours testing it, and it was really really interesting experience.
So when you're building this kind of content, are you using mostly your own developed technology, or are you using a combination of yours and other stuff that's on the market?
Yeah, so the ecosystem's filled with all sorts of different tools. A lot of the tooling comes from sort of the same sort of stuff that's used in 3D video games.
Yeah.
Specifically, we're using the Unity game engine as sort of our base tool. Okay. And then we're using some of our homegrown technology within the experiences as well.
Excellent.
Yeah.
So obviously we're not quite at the, I mean, that's great. What's the next leap forward in the VR space that you see coming?
Yeah, so the major things that need to happen, well, we need untethered headsets. So headsets that display high quality VR.
Yeah.
We usually call them tethered or like high-end HMDs. Those would be like the Vive and the Oculus. They have a cable that runs from them to the computer.
Right.
And that's kind of limits you to five-ish meters distance from your computer. That needs to be gotten rid of. There's a few different people working on that problem.
Okay. Because the ones you put your phone in, they're not there yet, right?
Yeah. So the ones you put your phone in, they have they're kind of like less powerful hardware, so you don't
Yeah.
get as high fidelity in your experiences. So there's two directions that's being approached from. One of them is, how do we get the information from the computer to the headset without a cable?
Right.
There's sort of these wireless, TPcast is one of the companies that's doing that. And then the other one is, how do we get phone hardware to be good enough to show good experiences and
Right.
also make it support motion tracking other than just like the rotational tracking that you
Yeah.
get now. And that they do with cameras that they place on the headsets, and they use what the camera sees to sort of determine where you are
Okay.
in the room. And those are called 6 degree of freedom mobile headsets. And HTC is releasing the Vive Focus this year.
Okay.
That works under that principle.
Yeah.
Yeah. So that's one of the first things that needs to happen. The next is our sort of redirected walking algorithms need to become pervasive and available for everybody.
Right.
We need better motion controllers for mobile VR headsets.
Yeah.
Right now we're limited to 3 degrees of freedom on mobile VR, and so that's a big barrier to consumer adoption. Price is still a barrier that needs to come down.
Okay.
And then haptics.
Yeah, interesting. Well, sounds like there's a lot to do still, but companies like yours are obviously working hard away at it, and you're not the only one in Nova Scotia. I know we were talking earlier before the show, and
Yeah.
there's a whole bunch of companies in Nova Scotia that are in the VR space, and we're just a small province. So if that's Nova Scotia,
Yeah.
obviously a lot of other companies out there doing.
Yeah, it's happening everywhere. Yeah, there's been a lot of investment in VR over the last 3 to 4 years. It's one of those. There's sort of a hype cycle with every
Yeah.
new technology,
Absolutely.
and that there's often early on a kind of hype and acceleration of that kind of investment, and then there's sort of a wait to see how those
Yeah.
things do, and then it kind of picks up again after this sort of
Yeah.
like disillusionment phase that people go through. And I think that VR, everyone was really excited about it in 2013 and 14.
Yeah.
And it took a little bit longer to get going than people had hoped. So there's sort of a disillusionment phase that happened over the last, I don't know, maybe last year or something. But we're starting to see all the interest pick up again, and with AR getting more and more convincing all the time, they sort of feed off of each other.
And there's
Yeah.
got to be the business case as well, which helps fund the money and
Yeah.
the flow of resources into the
Yeah, exactly.
into the research
So
right. So,
the more customers we have, the more people buying VR content,
Yeah.
the better that is for everybody.
absolutely.
Yeah.
Well, thank you very much. I appreciate you coming and talking to us today. It's been an education. It's always interesting to learn where these, the roots of these technologies are coming from, and how they're being developed and what they can do for us. And no, I really appreciate it. And yeah,
Thanks
Cheers.
so much for the beer
Yeah.
and the good conversation.
absolutely. Thank you. Thanks everybody. And again, live here at the Celtic Corner, and look forward to seeing you next time.